All right, we're going to go ahead and go over these. All right, on number one, y'all really kind of overthought this one. Instead of doing the fractions, what if I said that the tube was 10 inches long and we're going to cut 3 pieces that are 2 inches each off, and I want to know what's left. The tube is 10 inches. We cut 3 2-inch pieces off. How much is left? Okay, I'm asking again. 10-inch piece of tube. We cut 2 inches off, then we cut another 2 inches off, then we cut another 2 inches off. How much is left? Y'all got to think. It can't be 2 inches. If the whole thing is 10 and I take 2 off and 2 off and 2 off, that's 2, 4, 6. There's 4 inches left. Y'all making this way too hard. So why is it that when we throw fractions in there instead, everybody freaks out? I'm not doing anything different. The pipe is 71 7/8 inches long. We're going to cut one section off that's 22 1/4 inches. And then we're going to cut another section off that's 22 1/4 inches. And then we're going to cut a third piece off that's 22 1/4 inches. The piece that's left is what's left over. Well, over here, when we said we were taking 2 inches off and 2 inches off and 2 inches off, what arithmetic did you do? I'm taking off 2 inches. I'm taking off 2 inches. Taking off 2 inches. What arithmetic do you have to do if you have 10 inches and you take 2 inches off of that? Okay, right, we subtract. So that's exactly what we're going to do here. 71 7/8, and I'm going to subtract off 22 1/4. This is one way to work the problem. There is another. We did a whole unit on fractions where we learned how to subtract mixed numbers, and we can subtract the whole number parts and the fractional parts. The fractional parts, as long as we have a common denominator. I've got 8 and 4, So this is 71 7/8, but I need to change this to 8ths. And 1/4 change to 8, so we multiply the bottom by 2, multiply the top by 2. Then 2 from 7 is 5/8, and 22 from 71 is, off the top of my head, I don't know. Let's see, 71 minus 22 is 49. Thank you. Okay, so when we cut the first chunk off, there's 49 5/8 inches left. We have to cut another piece off. So I'm going to take 49 5/8 and I'm going to subtract another 22 1/4 off of that. So I need common denominator, which is 8. And 1/4 is 2/8. 4 times 2, 1 times 2. Then 2 from 5 leaves 3/8. And this gives us what? 7/27. So when we chop the second piece off, there's 27 3/8 inches left. So now I need to take the third 22 1/4 inches off of that. So I take 27 3/8 and I subtract 22 1/4. This is 27 3/8. This is 22 2/8. And so 2/8 from 3/8 is 1/8, and 22 from 27 is 5. You also have to look at your answer and see if it makes sense. Okay? If you answered that the piece that was left over was 214 inches, what's wrong with that? If you did all your stuff and you came out and that was your answer, why is that not the right answer? Right. That's more than what the original pipe was. How can you take a pipe that's 71 7/8 inches and start cutting pieces off of it and end up with a piece left that's 214 inches? That's not math, that's magic. We need to get you in front of a audience, put you on a show, because if you can take 71 7/8 inches and cut 3 chunks off of it and be left with 214 inches, you're going to make millions. Okay, so think about the reasonableness of your answer. Think about how reasonable your answer is. What's also wrong with -3 inches? What's wrong with -3 inches as an answer? There's a better reason than that. What is it about -3 inches? Come on, y'all need to wake up. Okay, but y'all are kind of dancing around it. The answer is there's no such thing as negative length. Draw me a picture of -3 inches. You can't do it. It's like in a black hole. You can't measure something and say, oh, that's -3 inches. There's no such thing as negative length. Length is always positive. So again, when you get an answer, stop and look at it for a minute and say, does that even make sense? Is that reasonable? Okay. Another way you could have worked this problem was you could have taken 22 1/4 inches, and since I'm cutting 3 pieces off, multiply that by 3. We learned in our fractions unit that you cannot multiply mixed numbers. You have to change them to improper fractions. So this becomes 89/4 times 3/1, and 89 times 3 is 267/4. Then change that back to a mixed number. 267 divided by 4 comes out to be 66.75, which is 66 3/4 inches. Then I have to take that. That's how much I cut off. It was all 3 pieces that I cut off. Then I have to take that and subtract it off of 71 7/8. And we've got to have a common denominator if we're going to subtract these. Common denominator is 8 times 2 times 2. Then 6/8 from 7/8 is 1/8, and 61 minus 66 is 5. All right. On number 2, what if I did this? And I said, how much is that? Okay, good. That's exactly right. So, why did that change when I went to this? Here was 0, here was 1. If you counted the hash marks, it took you 1, 2, 3, 4, 5, 6, 7, and I'm over by 1. So 1, 2, 3, 4, 5, 6, 7, 8. So it took me 8 marks to get over to 1. So that means each one of these is an 8. That's 1/8. That's 2/8. 3/8. 4/8. 5/8. 6/8. 7/8. And then 1 is 8/8. This is not any different from this. It's just one of them we're looking at a circle, the other one we're looking at a strip. We still cut it into 8 pieces. So each piece, each one of these pieces is 1/8. Okay. And I wasn't trying to trick you. I'm just trying to get you to see that, well, a couple of things. One is to take what you already know and apply it to a new situation. And second, to prove to you that you know more than you'd think you know. You've just got to make the transfer that we're doing the same thing, not doing anything different. I'm taking a whole unit and I'm dividing it into 8 equal chunks. like I had a candy bar, and I was chopping it into 8 equal pieces instead of it being a pizza and cutting it into 8 equal pieces. All right. On number 3. Some of you got the right answer. You gave me a problem that was equal to -2, but it was asking for an addition problem. Addition. I wanted to see something plus something. So, -4 plus 2 is -2. 5 plus -8. I mean, -6. No, -7 would be -2. So I was looking for addition problem. And then the last one, number 4, some of you said main idea, and that's correct. That's not wrong. The main idea is typically in the first paragraph. But what I was looking for was topic sentence. The first paragraph, the first sentence in a paragraph is typically your topic sentence for that paragraph. So remember when we were writing our paragraphs back last week and the week before, we had a main idea and then at least 3 supporting details that helped that main idea. And then when we started writing, we wrote a topic sentence as the first sentence in our paragraph. All right. Before we get into checking the homework, I have something I want you to see. It's just an interesting fact. Any ever heard of the Tacoma Narrows Bridge? The Tacoma Narrows Bridge. Okay, this was a bridge built in the 1940s. And what you're about to see is not an optical illusion. It is actually happening. People would come from all over to watch this, and they would also, some of them that were brave enough would actually drive across it until it collapsed. Whoops, wrong thing. Oh, really? And you never heard of the Tacoma Narrows Bridge?
Dawn of a fatal day, and the wind begins to speak with a roar that no man can fail to hear. In a 40-mile-an-hour gale, the center span weaves like a ribbon in a swinging twist that you wouldn't believe possible unless you could see it as you do now. There's an automobile caught on the heaving roadway. The 11,000-ton center span twists and strains the giant cables that support it. Cables of 6,300 wire strands, each 17 inches thick. Back out of the danger zone, all stricken spectators are driven to safety as the bridge gyrates like a nightmare high above the river, twisting, turning, curling. The lone motorist is forced to abandon.
I don't know if you can see it, but there was a car, and then there's a man that got out of his car because it started getting really wild, and he's walking down the center to try to That's the place where it's weaving the least, and that's him trying to get off the bridge. And you saw all those spectators. People would come and bring picnics and sit there and watch for hours and watch it do this. And then, like I said, some people would drive across it. They called it the Galloping Gertie.
Of the car, he has but a few minutes in which to save himself. Face to face with fate, his destiny hanging in the balance. Will he heed the last warning or perish with the doomed structure? But he saved himself by seconds. No structure of steel and concrete can stand such a strain. Steel girders buckle and giant cables snap like puny threads. There it goes! Engineers are divided as to the cause of the disaster. Some claim it was the use of solid girders. Others differ. But whatever the reason, Tacoma will rebuild. This time a bridge that will not provide a super thrill in the news.
Even today, when they build a suspension bridge over anything, they have to build a model of it. Yes, they did rebuild it. But even today, when they build suspension bridges, they have to build a model of the bridge first and put it in a wind tunnel and do the Tacoma Narrows test on the bridge. So every bridge after this bridge had to be tested by putting it in a wind tunnel and see if it would do this. So if the model did it, then they had to start re-engineering it, start from scratch and start over again. Okay, just thought that was interesting. I don't know why I thought about it, but I thought about it yesterday and showed my morning class, and then I showed my morning class this morning. All right, let's start with this one. So check your answers. And folks, I see that only 7 people turned in their assignment. I don't get it. All right, any questions about any of these? Any questions going once? All right. Thank you for coming in and letting us know. Everybody, Miss Powell has passed her third GED test. Math, science, is that right, Miss Powell? I forgot. Is it science? And now language arts. She has one more, social studies, and she will be a graduate. Congratulations, Miss Powell. That is fantastic news. I am very proud of you. Very, very proud of you. All right. Well, good luck on Saturday. Please let me know how you do. And I am overly confident that if you've passed all three of those so far, the social studies one is going to be a breeze. You should not have any problem with the social studies one whatsoever. So once again, congratulations. That is awesome. It shows what happens when you do the work. When you work hard, you do the work, do everything you're supposed to do, you get the reward at the end. All right, let me switch to the other sheet. You too, Ms. Powell. Again, congratulations. And hopefully I will hear from you next week. This should have been the one that was the said ordered pair relationships on it. All right, let's see. Those are probably, I bet, the ones about reflections. Okay, let's scroll down some. I think that's the bottom of that column. I'm going to go up to the top of the next page for the last two. All right, do we have any questions? I think it looked like y'all said 2, 3. And it looks like those were ones that were on reflections. Okay, well, let's take a look at those. So I'm going to turn this off. Okay, let's see what these said. All right, number 2 said that we have a point at negative 2.875, comma, negative 200. Okay, so on my coordinate grid, I would go in the x direction. It's always the first one, x direction first, y direction second. So from the origin, we would go to negative 2.875 would be maybe right about there. and then in the y direction, negative 200. So it'd be way, way down here. Okay, my graph paper is not big enough. Okay, but they said if we reflected it, this is in the third quadrant because this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And it says what kind of reflection would move the point to quadrant 4? So they want to know what would you have to do to get this point to be over here? Well, if you reflect it across the y-axis, this point would have to sit, and it's kind of hard to see that. There we go. So I would go to positive 2.875 and then go down to 200. And this would be positive 2.875, negative 200. Because when you're doing reflections, every point in your picture has to be the exact same distance away from whatever you're reflecting it on, whichever axis you're using as your reflection, as your mirror. And so this distance and this distance have to be the same. Well, from here to here was negative 2.875, so we'd have to go to positive 2.875 so that we would be the same distance away from the y-axis. I know my picture's not all that perfect, but then on number 3, they did that one a little bit different. All right, on number 3, they said we're giving you the point 3, negative 7. I think I can still do that one on this one. So 3, negative 7. We start at 0, 0. We go in the x direction first, so we would go to 3, and then we have to go down to negative 7. So that right there is the point 3, negative 7. It says it's reflected across the x-axis. So this time, this is the mirror. And so the reflection would be the exact same image on the other side, but it has to be 1, 2, 3, 4, 5, 6, 7 units away from the x-axis. So we would still go to 3, but instead of going down to negative 7, we would go up to positive 7. And so these are mirror images of each other across the x-axis because this distance and this distance are the same. They're actually 7 units. So whenever you're dealing with reflections, it is a mirror image, and every point on whatever it is you're doing, because you'll eventually get to where we'll have triangles, and it'll say reflect that across the x-axis. Well, that means we got a triangle that's sitting over here in a certain spot, and this point and this point have to be the same distance away from the x-axis, and this point have to be the same distance away from the x-axis, and this point have to be the same distance from the x-axis. So yes, it's kind of sort of, that's a good way of thinking of it. You sort of flip it over, and you flip it over the same distance away from the axis that you're flipping it on. This reflected over the y-axis would be over here somewhere, and we would have something that would look like that's a terrible drawing, but you would see it would look like this, but reflected across the other side. And this point would be the same distance away. This point and this point would be the same distance from the y-axis, and this point would be the same distance from the y-axis. Okay. And then number 10. said the point -15, 22 is in quadrant 2. Let's see if this grid is big enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, but we would go -15, 22. So it's going to be up here somewhere on this coordinate plane. What kind of reflection would move the point to quadrant 4? So they're going from 2 to 4. So yeah, this one was a toughie because you'd have to first of all reflect it across either the y-axis first. So if I do it across the y-axis, then this point has to be the same distance away, which is this. We went from here out to here, which was -15. So I'd have to go this way, +15. And it would have to be up 22. So this point would be 15, 22. That's the mirror image of this point across the y-axis. Then if you're going to reflect it across the x-axis to get it down here, then this distance would have to be the same as this distance. And so from here to here is 22. That's the y amount. So I'd have to come out to 15, that's where this was, and then go down to -22. So the point 15, -22 would be the reflection of this one across here. So to get the one from the second quadrant, I would have to either reflect it across the y-axis and then reflect it on the x-axis, or reflect it on the x-axis first and get the point that would be down here, and then reflect it across the y. Okay, so it would have to be C. I think the answer was C or D. Is that what the answer was? Because both of those are saying the same thing. A reflection across the x, and then a reflection across the y, a reflection across the y, and then a reflection across, no, D does not. It would not be a reflection across the y and then a reflection across the y. You'd go back over here. So it'd have to be over the y and then over the x. So the correct answer was C. Because you could also do over the x and get the point that would be right here, and then over the y to get the point that would be right here. Okay, hopefully that made a little more sense. All right, and then we had some reading homework. And I think it's number 1 that there's another one that's very close to it. Yeah, you almost every single question set almost every single question set on the GED, on the reading portion, you'll get a passage and then some questions. At least one of those questions is going to be, is it A, is it B? Is it A or is it D? There'll be two choices that you're going to go back and forth on. Most of the others in that question set are okay, but usually there's at least one. Sometimes there are two that they're so close and the wording on them is just not where you can just very easily make a decision. And I don't think I could give you any better explanation than what they are saying. The writer mentions internet SaaS and then goes on to say that you got to love it because it keeps writers off the street and out of trouble. And if I remember correctly, I think five was a little questionable too. There were two answers that, they're so close. And so their reasoning for C is that the reviewer talks knowledgeably about television and internet. Any other questions about those or need me to explain deeper or? All right. We have been talking about words, and we've all heard that the saying that words hurt. We've been talking about the fact that words, depending on what word you use, you can change the meaning of what you're saying. You have to be very careful with your wording. And so I had forgotten about these, but I'm going to show them to you. Anybody remember the Kmart commercials that were on for about a week back in the, I think it was the early 90s or maybe it was late 90s, early 2000s. I know some of y'all weren't born then. But I think it was either the early 2000s or very late 90s, 99, 98. It was somewhere in there. And Kmart ran some commercials and they were on for about a week and then they had to take them off because there were so many complaints about these commercials. So I want you to see these commercials. You're so funny. So remember, this was a Kmart commercial that was on the air for about a week, and then Kmart had to go and pull it off the air. Listen carefully. Wording is important.
Ship my pants? Right here? Ship my pants? You're kidding. You can ship your pants right here. You hear that? I can ship my pants for free.
Wow, I just may ship my pants.
Yeah, ship your pants. Billy, you can ship your pants too.
I can't wait to ship my pants, Dad.
I just shipped my pants, and it's very convenient.
Very convenient.
I just shipped my drawers.
I just shipped my nightie.
I just shipped my bed.
If you can't find what you're looking for in store, we'll find it at Kmart.com right now and ship it to you for free.
So do you see why words are important? Oh yeah, they did it on purpose. to try to get your attention. And then they ran this one. This one was in the same group. Words can change the meaning. All right. Like I said, those ran for about a week and then they had to pull them off the air. And actually, after they ran them, sales at Kmart skyrocketed. And they were so good and were doing so well that Sears bought them. And Sears owned Kmart. And maybe a couple of months after Sears bought Kmart, the sales started dropping and dropped so bad that Sears had to go out of business. That's why we don't see any Sears stores anymore. They bought Kmart, Kmart tanked and died, and so it killed Sears. All right. Today we are at the end of our unit on integers. And so you need to get out your notebook. We're going to talk about what we did in this unit. All right. The very first thing that we did was adding and subtracting integers. And there were several ways that you could kind of visualize it in your mind. I taught y'all the concept of using the chips. So for example, if I had positive 4 minus 6, and we let the positive chips be black chips, and the negative chips be white chips, for example. I think we used yellow and red. As long as you realize that one of these were positive and the others were all negative. And a positive and a negative cancel each other out. So those cancel, those cancel, those cancel, those cancel, and what's left is -2. Some of you prefer another method. I don't know what it's called, but some of you do this. When the signs are different, and this is not really a rule, but it's a way of approaching these problems. If the signs are different, this is positive, this is negative, then you forget the signs for a second and you take the biggest number, subtract the smaller number. If you take 7 from 11, you get 4. Then go back and look at the signs. This one's positive, this one's negative. Take the sign of the bigger number, even though -11 is not bigger. That's why I don't teach that, but that's the way some people can look at it and see it that way. Okay. Some people also think of money. If I have $4 but I owe $6, then I really owe $2. If I have $7 but I owe $11, I really owe $4. If I owe $3 but I have $5, then I really have $2 in my hand because I owe 3 of those dollars. Whatever works for you so that it makes sense and for you to be able to see it in your mind. But remember, we talked about the fact this was one of those things you got to know. You got to know your times tables from 1 times 1, 10 times 10. You got to know place value chart, and you got to know how to add, subtract, multiply, and divide integers. Then we did multiplying and dividing. And for this, there were rules. There are no rules for adding and subtracting, but there are rules for multiplying and dividing. If the signs are the same, we get a positive answer. If the signs are different, we get a negative answer. So, for example, 3 times 4, the signs are the same, so we get positive 12. Negative 2 times negative 8, the signs are the same, we get a positive 16. Same thing with division. 15 divided by 3 is positive 5, the signs are the same. Negative 20 divided by negative 4 is positive 5. The signs are the same. When the signs are different, negative 2 times positive 5, signs are different, we get a negative answer. 6 times negative 3, signs are different, we get a negative 18. 25 divided by negative 5 is negative 5. Signs are different. We get a negative answer. Negative 36 divided by 6 gives us negative 6. The signs are different. Our answer is different. Then after we did that, we looked at, let me see, I need to remember. After we did multiplying and dividing, then we did ordering. And we ordered all kinds of stuff. Positives, negatives, fractions, etc. So you had problems like 4, negative 2, 1.5, negative 1/2, and 3/4, for example. And we want this to go from smallest to largest. Okay, then you have to think about a number line and where these numbers sit on a number line. Okay, and we talked about the fact that on the positive side, as we move to the right, the numbers get bigger. On the negative side, as we move to the left, the numbers get smaller. So negative 4 is smaller than negative 1. Negative 1 is bigger. The closer on this side, the closer you are to 0, the bigger you are. You've got to keep that in mind. And then plot these points. 4 is right here. And negative 2 is right here. 1.5 would be, there's 1. 1.5 would be halfway. Negative 1/2 would be right here. And then positive 3/4 would be between 1.5 and 2. So the smallest number out of these is negative 2. Then we would have negative 1/2. Then we have 1.5. Then we have 3/4. And then we have 4. thinking about where the numbers lie on a number line, and then keeping our idea about which way is bigger, which way is smaller. Then after we did that, we did absolute value. And with absolute value, we learned that that meant the distance a number is from 0 on the number line. So if I have a number line and I have 0 here and I have 5 here, the absolute value of 5 is 5, because the absolute value of -6 is +6, because it's 6 units to get back here to -6. We learned that absolute value is always positive. And even though we had some answers that come out negative, those special cases were when the negative was outside the absolute value. Because these absolute value bars are telling you to do something. Just like when we write this, that's telling you multiply those, do the multiplication. When I do square root of 6, that means take the square root of it. Absolute value bars are the same way. It means take the absolute value of that first, which is 3, but the negative on the outside makes it negative, not the negative on the inside. And so this is an operation. The difference between this and this is that parentheses is not an operation. Parentheses is a bucket or a basket, and we put stuff in that basket as a way to group it together and keep it from, some people, when they eat their meal, they put the peas over here on one side and they put the potatoes over here. They don't let stuff touch, so they like to group their things together. This is grouping symbols. So this has nothing to do with an operation. This doesn't tell me to do anything other than -3 likes to hang out in that basket. But this is a not, which makes it a +3, because that's -1 times -3 is +3. So you got to remember that there's a difference between parentheses or brackets or braces and absolute value. Absolute value is an operation. It means do something. Don't just let it sit there. Do something. Then after that, we covered order of operations. And it told us the order in which we would do things in a problem that had lots of different operations in it. And we learned the saying, please excuse my dear Aunt Sally. P for parentheses or brackets or braces, some sort of grouping symbol. E for exponents. And remember, an exponent tells us how many times to multiply that number by itself. 2 to the 4th means 2 times 2 times 2 times 2. Then the M and the D stood for multiplication or division, not and, multiplication or division as you come to it from left to right. So just like if you were reading words or a sentence, we always start on the left and read to the right. We do the same thing with the order of operations. We do multiplication or division starting on the left and moving to the right. And then finally, the A and S stood for addition or subtraction as you come to it from left to right. And then we looked at all kinds of problems where we had to determine if there's a parentheses and then do what was inside of it, see if there were any exponents, etc. And then the last thing we did in this unit was since we were talking about number lines and we were talking about positive and negative numbers, that we could take and duplicate that number line, but turn it and put another number line going through 0, where we had a positive side and a negative side. This is called a coordinate plane, not an airplane. Coordinate plane is in flat surface. And coordinate meaning position. The word coordinate means position or address. And so we can give points an address by telling where they are in relation to the x-axis and where they are in relation to the y-axis. X is always first, Y is always second. X comes before Y in the alphabet, so that's how you can remember it. And so we would call that the x-axis. This would be the y-axis. And then if I needed to plot the point 1, -3, then I start at the origin. I go in the x direction, +1, and then in the y direction, -3. And so the point -1, -3 would be sitting right there. And so coordinate plane ties in with integers because we have positives and negatives, two number lines with positives and negatives that cross each other. Okay, so that was the unit on integers. And that's what we have spent a few weeks working on. So I have some classwork for you to work on. Okay, and I'm going to show you what that looks like. Okay, looks like this. It says integers review unit classwork on the top. It looks like a lot because it's 5 pages, but it's a lot of space in there for the diagrams and for you to do the work that needs to be done for them. I have that is 5:53. I think you can be done by 6:30 and take a break. So I'm going to put in chat here that you're going to take a break and finish this classwork by 6:30. Okay, so that gives you enough time to go grab something to drink or go grab a bite to eat, come back, sit down at your computer, and start working on these problems. Anybody have any questions of me before I take a break?
Yes.
Okay.
Mr. Bart, stop.
Yes, sir.
It won't let me write on it.
Then do it on paper.
Okay.
Now, you don't have to print these out. You can just do it on paper. And when you get to ones where you have to graph something, then use your, just make up a graph and estimate,
Okay.
And no, I can't walk and chew gum, so I have to do one thing and then do another. It's hard for me to be talking and check messages and all that kind of stuff. Okay. Once again, anybody have any questions of me before I go step away and take a break? All right, I'll be back in a few. All right, I'm going to go ahead, show you the answers, see if you have questions about these. All right, let me scroll down. That's the next section. Okay. Here's the first set with the number lines. Okay, here's the next. Okay. And hey. All right, scrolling up again.
What? You talking to me? Oh, okay.
Nope, range is difference between the highest and lowest. It's always subtract. All right, so any of those you need me to scroll back to? Number 6. All right, so we got 6, the perimeter one. Let me get something to write on here. 6, 11, 12, 13, 5, I, and J. And which one was the perimeter one? 13, okay. All right, 5, I. Okay, so 5I was parentheses 2 cubed plus 4 divided by 2 parentheses minus parentheses 6 squared divided by 4 times 2. Please excuse my dear Aunt Sally. So I look to see, do I have any parentheses? Yes, this is the first parentheses that I come to. So I go inside of that parentheses and ask, do I have any parentheses? No. Any exponents? Yes. So that will be the first thing I fix. 2 cubed means 2 times 2 times 2, which is 8. Then you write everything else down the same. You change one thing at a time. Then do we have any parentheses? Yes. Inside the parentheses, do we have any parentheses? No. Exponents? No. Multiplication or division? Yes. So this becomes 8 plus 4 divided by 2 is 2. Everything else gets written down the same. You do not change anything. Then do I have parentheses? Yes, I still have this parentheses. Inside of that, I can add those two things up and get 10. Since that's all that would be left, I can drop the parentheses, but then everything else stays the same. Then do I still have any parentheses? Yes, so I have to deal with that parentheses. And inside the parentheses, do I have any parentheses? No. Any exponents? Yes. So 6 squared means 6 times 6, which is 36, divided by 4 times 2. Then, do I have any parentheses? Yes. Inside the parentheses, do I have any other parentheses? No. Exponents? No. Multiplication or division? Yes. The first thing I come to. So the division gets done first because it's the first thing we come to when we move from the left to the right. That becomes 9 times 2. Then do we have any parentheses? Yes. Inside the parentheses, do we have any parentheses? No. Exponents? No. Multiplication or division? Yes. So this becomes 10 minus 9 times 2 is 18. And 10 minus 18 is negative 8. For J, You had 8. You had 8 for what? You had positive 8 as the answer? Okay. Then there's where you messed up. This is a positive 10. This is a negative 8. If I have $10 and I owe $18, I still owe $8. On J, we have bracket 3 plus parentheses 2 squared times 5 parentheses squared close bracket plus bracket parentheses 2 times 3 cubed minus 1 times 4. So do we have any parentheses? Yes, we have this great big bracket which acts as a parentheses. So then inside this bracket parentheses, are there any parentheses? Yes, I have to do that. So inside of that, do I have any parentheses? No. Exponents? Yes. So this is going to be 3 plus parentheses 2 squared is 2 times 2, which is 4. Everything else stays the same. You change one thing at a time. Then do we still have any parentheses? Yes, I have this giant bracket parentheses. Inside of the brackets, do I have any parentheses? Yes. So I have to do what's inside of that parentheses first. So this becomes bracket 3 plus 4 times 5 is 20. That'll be the only thing left. So I don't need the parentheses anymore, but it is raised to the second power. Everything else stays the same. We do not change anything. Then do we have any parentheses? Yes, we still have this giant bracket parentheses. So inside of it, do we have any parentheses? No. Exponents? Yes. 20 squared means 20 times 20, which is 400. Plus bracket parentheses 2 times 3 cubed minus 1 times 4. Do we have any parentheses? Yes, I still have this giant brackets. Inside of that, I can add 3 and 400 and get 403. The brackets can disappear because there's nothing left inside. Then any parentheses? Yes, I have another big bracket. Inside of it, do I have any parentheses? Yes. So I have to do what's inside that parentheses. And what is inside that parentheses is 2 times 3. So that gives me 6. I can drop the parentheses since there's nothing else left in it, but I am raising it to the third power. Okay, then let me erase some of this one. Pick back up right here. We have 403 plus. Do I have parentheses? Yes. Still have this giant bracket. Inside, are there any parentheses? No. Exponents? Yes. So this becomes 6 cubed means 6 times 6 times 6, and that's 216 minus 1 times 4. Then do we have any parentheses? Yes, we still have this bracket. Inside of that, do we have any parentheses? No. Exponents? No. Multiplication or division? Yes. So inside we have 216 minus 1 times 4 is 4. Then do we have any parentheses? Yes, we still have a giant brackets that we need to fix. And so 216 minus 4 is going to be 212. And we can drop the brackets because there's nothing else left inside. And then 403 and 212 is 615. If you can do that one, you can do any of them that they're going to give you on the test. Okay, and I'm telling you, it's easy to make a mistake, because this morning I actually had to redo this answer sheet because this morning I found out I had screwed up. I went from this step right here, and instead of writing a 3, I wrote a 2. I didn't catch that this was cubed, and I changed it to squared, and it threw off the whole answer. One little teeny tiny mistake. Okay, but that should be evidence to you that we all make mistakes. I have a bachelor's of science in applied mathematics, and I screwed that up. It happens. We all make mistakes. And the thing is it's okay to make mistakes. We've been conditioned to think that making mistakes was bad, but it's not. Making mistakes is good because we learn from them. I have a poster up in my office. It says, "I never lose. I either win or learn." I never lose. I either win or I learn. And so a loss can be a mistake. I make it a learning opportunity. All right, that was 5A and 5I and J. And then we have 6. So let me clear all this out. All right, so on number 6, okay, what part of number 6 did y'all want? I mean, are you wanting me to plot all of those points? So I'm not sure what you meant by number 6. Okay. Oh, okay. Okay, well, this answer sheet is also in Blackboard, so you can pull it back up in Blackboard. Number 11. All right, on number 11, when we have a large angle that's a right angle, okay, and then there's a smaller angle in it that's 21 1/2 degrees. Well, this is 90 degrees. It shows that you have a right angle. So think of this as a pie or something. This much of the pie is 21 1/2. So to find out what the rest of this is, you take 90 and subtract 21 1/2, and you get 68 1/2 degrees. 68 1/2 plus 21 1/2 add up to 90 degrees. On number, oh, that wasn't number 6, that was number 11. Sorry about that. Oh, come on. Okay. Sometimes this thing flakes out. This is number 11. So then number 12 is the same basic idea. They tell you this is 31 degrees, this is 42 degrees, this is 65 degrees. They want to know, what is this? Well, if this much is 31 and this much is 42 and this much is 65, then to go from here over to here, you went 31 degrees, then 42 more degrees, and then 65 more degrees. 65 plus 42 plus 31 is 138 degrees. Okay, on number 13, okay, our diagram looks roughly like that. We're told that this is 30 yards, this is 10 yards, this is 6 yards, this is 9 yards, this is 12 yards. Okay, I don't know this length, or this length. Perimeter means add all the sides. 1, 2, 3, 4, 5, 6, 7, 8 sides. But I don't know 3 of them. Well, from here to here is 10. Think of a wall of a house. If this side is 10 yards, this side of the house has to be 10 yards. Be an awfully funky house if you had one wall was 10 yards and across the room it was only 7 yards. Then the same thing up here. If from here to here is 30, then so is from here to here. Well, we know this much is 9. And we know this much is 12. So this much has to be 30 minus 12 minus 9, which is also 9. So this is 9 yards. So we found out this was 10 yards, this was 9 yards, and then this side is the same as this side. That length is the same as this length, so that's 6. So we add up the sides. 30 plus 10 plus 9 plus 6 plus 9 plus 6 plus 12 plus 10 all add up to 92 yards. All right, anything else from there? And it's funny to me sometimes because the ones that I think y'all will get right very easily are the ones y'all end up having questions about, and the ones I think, oh, that's going to be hard, y'all seem to get those right. I don't know what the deal is. All right, today is oh yes, we will be doing more geometry. Absolutely. Today is vocabulary and grammar. And so first we have list number 8. So let me get that to you. Okay, so if you want it now, but it's also in Blackboard. Okay. Okay, and y'all should know me by now. If you get a vocabulary list, what is eventually going to happen pretty soon? Yep. Won't be in tonight's homework, but probably when you get back from Thanksgiving holidays. So be ready. All right. Depict, meaning to portray in words or to describe, can also be a drawing or painting. So in other words, if you are drawing or trying to describe something in words or with a painting, you might say that photograph depicted an angry man. Precise means exact, accurate, detailed. Math, science are very precise. Procedure, an official way of doing something, a series of actions conducted in order. So, for example, a good example for us is order of operations. Please excuse my dear Aunt Sally. That is a procedure. We do things in an order. Amiss, inappropriate or out of place. Sometimes you might hear somebody say, well, I would be amiss if I didn't tell you about the Thanksgiving holidays. Or his comments were amiss. Derive means to obtain something from. In other words, to make something from something else. We derive lumber from trees. We derive paper from trees. All right, so that is our vocabulary. There are 3 videos, but one of them is really, you can't hardly hear it. So I'm not going to try to play it, but you can play it, and that way you can turn the volume up so you can go into Blackboard and go into today's folder. And it's the first grammar video, but the other 2 are okay. So and
Improvise. Type a prompt and generate a persuasive.
We speak student.
Wordiness, a la Schmo. Mr. Zazzles, the algebra teacher, has some bad news that's truly terrible. He just wants to let his students know that they're going to have to go ahead and do those 50 problems from page 127 for homework during the Thanksgiving holiday. If Mr. Zazzles' students don't break out the pitchforks and torches over his homework assignment, they'll send him to the guillotine for his wordiness and redundancy. Well, when we want to get someone's attention or sound important, we sometimes shoehorn extra words into our sentences. We get wordy.
You could say that I run things around here.
Redundancy is a kind of wordiness. It involves saying the same thing in a sentence more than once and sometimes in a different way.
okay, that's important. Redundancy is a type of wordiness. It involves saying the same thing in a sentence more than once, and sometimes in a different way. It can also be in a paragraph. Remember, we were writing our paragraphs, and I said, don't let your details be the same. You have 3 different details that you're going to write in your sentence, and you don't keep using the same words over and over.
While wordiness and redundancy can be annoying to listen to, they are really annoying to encounter in written sentences. For example, when Ms. Brazel, the science teacher, puts a note on a lab assignment that reads, "It is absolutely essential that students not mix chemical A with chemical B in as much as that would cause a massive explosion," oh, she's guilty of wordiness. The word essential doesn't need to be preceded by absolutely, and Ms. Razzle could have used since or because instead of inasmuch as. When Ms. Doe, the cook, puts a sign up at the beginning of the lunch line that reads, "Owing to the fact that we made too much broccoli, spinach, and cheese casserole today, go ahead and take 2 helpings," she's guilty of wordiness, not to mention crimes against vegetables and cheddar. The phrase "owing to the fact" could be replaced with "because," and that "go ahead" could just be cut from Ms. Doe's sign altogether. When Mr. Moe, the history teacher, puts in his syllabus, "The required midterm book report has a required length of 5 pages," well, he's guilty of redundancy. A redundancy-free sentence might read, "The midterm book report must be 5 pages long, period." When Mr. Yo, the English teacher, leaves a note on the whiteboard that reads, "The writing assignment for the day is to write a poem about writing," well, he too is guilty of redundancy. He might have written, "Today's assignment is to compose a poem about writing." When Ms. Johnson, the PE teacher, writes in her journal that the reason she loves Thanksgiving break is because she doesn't even have to think about work, well, she's also guilty of redundancy. A redundancy-free sentence would be rewritten to exclude either the reason or is because, as these 2 sets of words mean the same thing. Wordiness and redundancy are easy to avoid. Just look for those extra words or phrases that muddy up the construction or the meaning of a sentence. And snip those suckers. Get rid of them. You don't need them. Now, if only Mr. Zazzles would learn that using unnecessary words to announce holiday math homework does not make that homework less awful or his students less vengeful.
Help!
Subscribe to check out more equally fantastic.
Okay, and then one more.
Wix is your platform to perform on. A complete portfolio.
Writers use language that expresses their ideas concisely and precisely. Let's practice eliminating wordiness and redundancy in our writing. Sometimes writers become wordy and redundant by using words that are not necessary or repeating the same ideas in their paragraphs. Wordiness is using empty words that carry little meaning. Redundancy is repeating words or ideas over and over.
So wordiness is using empty words that carry little meaning. You ever talk to somebody that wants to sound like they're overly educated and they stick all of these extra fancy words in sometimes? And a lot of times the words don't fit, they don't make sense, they don't have much meaning. And redundancy is saying the same word over and over and over and over and over and over. So wordiness is using empty words that carry little meaning. Redundancy is a repeating of words or ideas over and over.
Wordiness and redundancy can distract readers from what we're trying to say. Writers remove unnecessary words and repeated ideas to make their writing precise and concise. When we are wordy or redundant, we can distract our readers from the real meaning of our sentence. As we revise our writing, we need to be on the lookout for unnecessary words and words that we repeat over and over. Let's look at an example. Here's my original sentence. My mom was driving in her car when she suddenly slammed her car brakes. She slammed her car brakes because there was a squirrel in front of her car. As I'm revising, there are a few things I need to do. First, I look for words being repeated over and over. I notice that car and car brakes are written a few times. I also need to look for sentences that have many words but little meaning or ideas that might be repeated over and over. As I reread, I notice that my second sentence really just repeats the ideas from the first sentence about my mom slamming on the brakes, and then adds that there was a squirrel. I ask myself, can I remove or replace these words to make my writing precise and concise? Well, I think I can. I'm going to remove the car brakes, and slammed, combining the 2 sentences into one to make my writing less wordy and redundant. Now my sentence reads, My mom suddenly slammed on her car brakes because there was a squirrel in front of her car. I've trimmed my writing down to one sentence that precisely and concisely expresses what I want to say. Pause the video and write these sentences on your practice sheet. Press play when you're done. Here's a draft of an argumentative letter I've been working on. I'm trying to convince our school board to adopt a uniform policy. I think I have great support for why uniforms will be a good idea, but I don't think the style of my writing sounds very convincing. I need to check for redundancy and wordiness. Read my draft and see if you notice any redundancy and wordiness in my writing. Let's look at the first part of my draft. As I begin to revise, I'm going to ask myself, which words do I use over and over in my writing? Try this on your own. Pause the video and underline the redundant words. Press play when you're done. So let's look at the words we underlined. Remember, we asked, which words do I use over and over in my writing? I decided to underline academic achievement because I used that twice. I also used the word uniforms 3 times. I don't think I need to keep repeating these words. The next question I ask myself is, how can I reword the sentences to make my writing more concise? I know that I don't need to repeat academic achievement and uniforms over and over. So here's what I came up with. I decided that I didn't need to say our students wear uniforms at the end of the first sentence because that idea is redundant. I've already mentioned a uniform policy, so I don't need to add that the students will wear the uniforms. In the second sentence, I can drop academic because I've already mentioned academic achievement. I can just write achievement. I've also dropped the word uniforms because my reader already knows that I'm referring to kids wearing uniforms. So my revised sentences read, our student academic achievement will increase if we adopt a uniform policy. First, achievement will increase in the classroom because students will concentrate better. Doesn't that sound much more precise? Pause the video and write the revised sentence on your practice sheet. Press play when you're done. Okay, here is the next section of my draft. First, I will ask myself, which words do I use over and over in my writing? Well, first I notice that I say thinking about twice. I also refer to distractions twice. I bring up adopting a uniform policy again, even though I've mentioned that a few times earlier in my draft. I also notice that I say academic learning. The academic is redundant because I'm talking about school, and that is obviously academic. Now that we've noticed the words that are used over and over, try the next part on your own. Remember, ask, how can I reword the sentences to make my writing more concise? Pause the video and write these sentences more concisely. Press play when you're done. Nice work! Do your sentences sound more concise and precise? Listen to my revision. Kids are not distracted by what the person next to them is wearing during class or by the clothing they want to have. Because these distractions are gone, more concentration can be put into the learning that should be taking place. I'm really pleased with how much smoother that sounds. Here's the final section of my draft. Read over this section, asking yourself, which words do I use over and over in my writing? And how can I reword my sentences to make my writing more concise? Pause the video, find the redundant ideas and wordiness, and then revise the sentences so they are more precise and concise. Press play when you're done. Fantastic work! I'm sure you can see a huge difference in this writing now. I'd like to share my revision with you, but first, notice where I underlined redundant ideas and wordiness. And now, listen to my revision. A uniform policy helps to put students in a learning frame of mind. Students know that they are dressed for school and academic achievement. They can separate their behavior in street clothing from their behavior in uniforms. When kids dress for success in uniforms, everyone wins. I took a good look at my paragraph, recognized the wordiness and redundancy, and now I have a clear paragraph that really drives my point home. Okay, I've worked my way through my draft, asking myself, which words and ideas do I use over and over in my writing, and how can I remove or replace them to make my writing precise and concise? Now my revision is complete. Press pause and read my revisions to yourself and see what you think. Now it's your turn to give it a try on.
All right, we're not going to do that. All right, I have some classwork for you to start on. So take a look at that, get started on that. We don't have a lot of time left, but you might be able to get a little bit of that done. All right, time is about run out on us. The answers to this are in Blackboard, so I will show you where that's at. Okay, and so on our folder page for today that will open up at 8:30, you'll be able to see it at 8:30. Let's see, there are the math videos we watched. Here are some guided practice sheets that I did not do. But if you want to try them, they're here for extra practice on order of operations and absolute value and so forth with the answers. Yes. Am I not in 4 o'clock? Yeah, I'm in 4 o'clock. Y'all are in the 4 o'clock session. Okay. And so here's extra practice if you want it. There was the classwork that we did today. If you want to go back over answers again, there's the answer sheet. There's a vocabulary list. This is the video that plays really low, so you may want to listen to it. There was the 2 videos that we did. Here's the worksheet that you're working on now. Here are the answers. You do have an assignment, and so I would finish this and take a look at the answers so that it will help you with the assignment. And then here's your math, and then here is the language, the grammar. And so, yes, you do have homework over the Thanksgiving holidays, but that's because a lot of you are going to should be taking some tests when you come back, and so you need to be ready to go on that. Remember that next week is Thanksgiving. There are no classes. So there's no class on Monday. There's no class on Tuesday. There's no class on Wednesday. There's no class on Thursday. No class on Friday. We come back the week after Thanksgiving. The week after Thanksgiving. So you have a whole week off. That gives you a whole week to do this assignment, these 2 assignments, and get them turned in. So next week is a break. Those of you that, yes, the 20, I think that Tuesday is the 28th, if I'm not mistaken. Yes, the 28th will be your first day back. And then we only have, I think it's 6 weeks until Christmas and the semester is over. And we'll be starting fresh. If you have taken a test recently and you know you have not sent me your scores, you need to send me your scores, because we need to be looking at that stuff and making decisions about what you're going to do when we come back from holidays to get some of you or more of you with your GEDs taken care of. Okay. Just if you want to send a screenshot, that'll be fine. Or just in an email, tell me what the scores were. That will be fine. Okay. And now yes, your GED ready scores. Or if any of you have taken a GED, some of y'all may have taken a GED and just don't want to tell anybody. I would be wanting to shout and scream and yell, but you might have taken a GED and not told me what your score is. I need to speak with, and so these following people need to stay. I need to speak to Miss Morrison, Miss Proctor, Mr. Thorne, Miss Wiley, and Miss Corkery. Okay, Miss Morrison, Miss Proctor, Mr. Thorne, Miss Wiley, and Miss Corkery. I need you to stay behind for just a minute. I do not have a ticket out the door. Please have a wonderful Thanksgiving. Spend time with your family. Be safe. And I will see all of you in a week. Yes, we come back on the 28th. Back on the 28th. Okay, so everybody have a great Thanksgiving. And I will see you on the 28th. And again, I need Miss Morrison, Miss Proctor, Mr. Thorne, Miss Riley, Miss Corkery to stay behind just a minute. Okay, good night. Y'all be safe. Okay. So I have Miss Corkery, Miss Wiley, Miss Morrison, Mr. Thorne. Okay. Miss Morrison, Mr. Thorne, and Miss Wiley. You have been assigned reading and social studies GED ready vouchers. They have made a couple of changes. You don't have to schedule that anymore. It used to be you had to call and schedule your GED ready test because you had to be proctored. They have dropped that in just the last week. And so you go into GED.com and you, as soon as you log into GED.com, it should pop up on your screen that you have vouchers to take the reading and the social studies GED ready test. You're not taking the GED, you're taking the ready test. You need to do that and send me your scores. Okay. Miss Corkery, your social studies came through, so you are ready to go on and take your social studies ready test. And so you log into GED.com. There's no proctor. You take the test. You still need a proctor for a post test, and you still have to have a proctor for GED. But for the GED ready test, you no longer have to have a proctor. You can just do that sitting right there in your house. Okay, so go into GED.com, click on your vouchers, take those tests, and then send me your scores so that we can talk when we come back from the break. We can talk about what your next steps are. Yes, you can do that at any time. No scheduling anymore. You just go in there and do that. Okay, so that's all I've got. Please make sure that y'all have a good holiday. Don't forget to do that. Don't forget to do your homework. And I'll see y'all on the 28th.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.